In this example, we have a crane that's lifting a 20-meter long pile up into the air at a rate of 0.5 meters per second. We want to find what the velocity of the bottom of the pile is as it drags along the ground when our angle theta is 70 degrees. Now we could use absolute motion analysis to solve this, and we could probably even use relative motion analysis, but we're going to solve this problem using instant centers. We'll start by drawing the pipe. If this is our pipe, we know that the velocity at this end of the pipe is straight up, and we know that the bottom of the pipe is confined to the ground and it's going to drag along the ground, so its velocity is going to be that direction. To find our instant center, we draw lines that are perpendicular to our velocities, and where those lines cross is where our instant center is located. So in this case, our instant center is right here. We know that this velocity is 0.5 meters per second. We know this length is 20 meters. We're going to label this point A and this point B, so this will be our radius to A, and this will be our radius to B. To use instant centers, we're going to use the equation V equals omega times R. So we have to define what RA and RB are. We can define RA as 20 times the cosine of theta, and RB as 20 times the sine of theta. Now, knowing that velocity of A is equal to omega AB times the radius to A from our instant center, so we know that the velocity of A is equal to omega AB times the radius to A from the instant center. So omega AB is equal to the velocity of A divided by the radius of A. The velocity of B is going to be equal to omega AB times the radius to B. Substituting in what we solved for omega AB, the velocity of B is equal to the velocity of A over the radius of A times radius to B, or position of B. Then substituting in what we know, velocity of A is 0.5 meters per second. Radius to A is 20 cosine of theta, and the radius to B is 20 sine theta. Our 20s will cancel, so we're left with 0.5 meters per second times the sine over the cosine, which is the tangent of theta. In our case, 0.5 meters per second times the tangent of 70 is equal to 1.87 meters per second. That's the end of the problem.